Addie, this lesson is so fun. This is going to be a good one. This is lesson 2 on angles, polygons, triangles, quadrilaterals, all of these super fun things. Before we jump into that, just a fun little meme for today. Start every phone call with, "My phone is about to die." That way you can hang up on them whenever you want to. I don't know why I've never thought of this. This is genius. Oh my gosh. I'm going to totally try that out. Okay, let's jump right in because I'm super excited about this lesson. I think you're really, really going to like it. We are going to start talking about lines and angles. Now, these are called intersecting lines. That means, of course, that just like at an intersection, like a road intersection, these lines intersect one another. Totally makes sense. They're intersecting lines. Now, these lines are like a perfectly designed highway where one side is going north and one side is going south. They are parallel lines. And in theory, in a perfect universe, parallel lines are never, ever, ever, ever going to cross. So they don't become intersecting lines. In fact, if they're like barely going in one direction, like closer to the other line or slightly farther away than the other line, then they're no longer parallel lines because they will intersect at some point. So they have to be perfectly parallel lines to be called parallel. Okay, now a couple things about intersecting lines. This point in the middle has a special name, and this is called the point of intersection. And that just means the place where they cross. All right, now let's look at some other types of lines because lines can cross in other special ways. For example, you can have a right angle. So obviously when there's a little square there, I just erased all of that. Whoops. Okay. When there's a little square like that, that means that it is a right angle. The other thing that you can say is that these lines are perpendicular to each other. That means that when perpendicular lines cross each other, they form right angles. And that also means a 90-degree angle. And that's why we draw a little square right there at the intersection or the point of intersection. And that basically indicates that all 4 of these angles are going to be right angles. If you have 2 right angles together, like this, like you have one line here, and you have 2 right angles, one there, then this is called a straight angle, which is ironic because I put a rainbow and that is not that's not the symbol of being straight. But in fact, you know what? I'm going to erase it. But what I was trying to show there is that a straight angle means that these 2 angles, when you put them together, basically this part is a straight line. Okay, and it always has a measure of 180 degrees. And that makes sense because it's 2 90-degree angles put together. All right, one other thing about these intersecting lines, of course, make angles. So there's an angle. Sometimes we give it a name like theta, or sometimes we give it an X name, like, it's X degrees and you have to find it. But there are a couple of vocabulary words to learn. One is obtuse. The way I remember this is it is a big fat angle. It's greater than 90 degrees. Anything greater than 90 degrees is an obtuse angle. And so I think of the word obese because it's a big fat angle. Okay, and then a little angle, anything less than 90 degrees, that means that it's acute because it's a cute little angle. Get it? A cute little angle. So I put a cute dog there to help us remember that. So these angles are both obtuse and these angles are both acute. And in fact, when they are opposite each other like that, then the angles, turns out they are the same. But we're going to learn a little bit more about that later. I can't talk. It's late at night. Of course it is. Now, if a right angle, let's look at a right angle. Here's a right angle right here. Of course, 90 degrees. So what does it mean that it's 90 degrees? It means if you take two lines like this, you put them like that, and then you divide this, like pretend this is a piece of pie or something, and you have to divide it 90 into 90 pieces. If you had to divide it into 90 pieces, everyone would get a tiny, tiny little slice, but turns out each slice would be the same measure of degrees, and it would each be 1 degree. So if you divide an angle like this into 90 pieces, they're each 1 degree. So this altogether is a 90-degree angle. Of course, in a straight angle, like we just mentioned, a straight angle is 180 degrees, so it goes all the way from here to here. And turns out if you put 4 right angles together, like whoopsie, I keep doing it, 1, 2, 3, 4, then you get 360 degrees in a whole circle. And that makes sense. You can tell from the picture that it's going to do that, but you can also tell if you do 90 plus 90 plus 90 plus 90, or if you figure out what is 90 times 4. So that is going to make 360 degrees. So cool. These ideas are so cool. You're going to love when you get to the homework and do the questions because they're just so fun. They're like solving little mysteries. Super fun. Okay, let's move on to polygons. Now, the word poly comes from the Greek root poly, which means more than one, or it means many. And gon comes from the Greek root gonan. I don't know how to say that, but anyway, it means angle. So many angles or more than one angle. So a polygon is a shape that has more than one angle. That's the literal meaning of it. But some modern day authors have more specific parts of this definition. And these are the things that it has to satisfy in order to be a polygon. It has to be simple. You have to check that box. It has to be closed. So it can't be an open shape. An open shape means the lines don't meet at the end. They have to totally, completely meet and form a closed space. So it has to be closed. It has to be flat. So I guess 2-dimensional, not 3-dimensional. And what else? Oh, it has to have, the sides are all line segments. So it can't have a curvy piece. They have to be straight lines connected to each other. Something like that. That wasn't a very good picture, but let's look at some pictures. So turns out these are all not polygons. Spoiler alert, these are not polygons. So let's start with this one. This is not a polygon because the line segments cross. So you can't have an area like this that crosses another line. If they do cross, that means it is not a polygon. Okay, what about this one? Okay, look, the lines cross again. So no thank you, that is not a polygon, doesn't count. Okay, what about the next one? What about this one? This is open. Look, we said it has to be closed and there's a space here. So that does not count as a polygon. It looked like the letter G, that little shape, but anyway, not a polygon. This one looks like a letter D. And that's also not a polygon because of this line. It has a curvy line in it, so that can't be a polygon. It has to have all straight lines. Okay, let's look at some examples that are polygons. Yay, these are all polygons. Okay, so the first one, I'm going to give it a name. Okay, so obviously you know what this is. This is a triangle. It has 3 sides and it has 3 vertices. That means 3 angles or 3 vertices. It's the plural of vertex. The next one, this is a quadrilateral. It has 4 sides and 4 vertices. This one is a pentagon. I always remember this one because to me it looks like kind of a house. So I think of the word tent, which rhymes with pent, and it makes a pentagon. So it has 5 sides, 1, 2, 3, 4, 5. Okay, and then this one, this is called a hexagon. This is 6 sides and 6 vertices. And I kind of remember that because 6 has an X in it and hex has an X in it. The next one is called a heptagon. So H-E-P-T. Heptagon has 7 sides and 7 vertices. I don't know a great way to remember that. Maybe you have an awesome way to remember it. How do you remember that heptagon means 7? You let me know. Put it in the comments below. Or no, just seriously, don't do that. Just text me. I'm never going to see that. All right. A polygon with 8 sides is called an octagon. That totally makes sense to me because octopus has 8 tentacles. So of course an octagon is going to have 8 sides and 8 vertices. So these are all polygons because they satisfy the conditions, right? They're all straight lines. They're all closed. They're all simple. They're all flat. All of those things, even though they are different shapes and they could be different. All right, let's look at a couple of vocabulary words here. And one of them I already told you is the word vertex. So each segment of a polygon, so when I say segment, I mean this part, a line, the side of the polygon. This is called a segment. And each end point of a side is called the vertex. Okay, so this is the vertex. It's not the angle, it's the end point of the side. So it's the end of this side and the end of this side, and that's a vertex. The plural of vertex is vertices, just so you know. And guess what? This is really cool. The number of sides, whoops, I just threw my pencil. Sorry about that. The number of sides, so like, for example, if we're talking about a triangle, the number of sides, 1, 2, 3, is always equal to the number of vertices. So vertices are the end points, so 1, 2, 3. So vertices are the pointy part, basically. All right, let's go over, we did this already, the names of some of the polygons. Triangle means 3. Quadrilateral, quad means 4. Like quarter, there's 4 quarters in a dollar. What else has that prefix? I can't think of anything right now. You think of something. Pentagon sounds like tent, which looks like that and has 5 sides. Hexagon has an X in it, so there's 6. Heptagon is 7. Octagon, like an octopus, 8 sides. Nonagon means 9. That makes sense because of all the ends. There's 2 ends in it, and N is for 9. Decagon, dec means 10, and that makes sense to me because of the word decade, which also means 10 years. What else has that prefix, dec? I don't know. Something else, something probably with a 10 in it. What about an undecagon? An undecagon, the UN kind of means 1 to me. So it's kind of like 10 plus 1, which is 11. So undecagon means 11 sides. And so you can kind of remember undec, like uno is a 1, and then add that to the decagon, which is 10. So it's 11. What about a dodecagon? A dodecadon is do kind of means dos, like in Spanish. So it's like 2 plus 10, so it's 12. Anyway, if it has 12 sides, it's a dodecagon. Cool, huh? If they have more than 12 sides, what are their names? We don't use those very often, so you don't have to memorize anything bigger than that. Like, what if a polygon has 42 sides? What you would say is it's a polygon with 42 sides. Or you could say an n-gon. So what do they mean by that? If it's a 42-sided, you could say 42-gon or a 42-sided polygon. Anyway, so that's it. Okay, here is the queen giving you applause for everything you've done so far in this lesson, and so sad that she died today. Some people are really super sad about that, but sounds like she had a really nice, long life. All right, let's talk about concave and convex polygons. Okay, so if a polygon has an indentation like this part, then that's like a cave. It looks kind of like a cave to me if it were a big rock. And this is called a concave polygon. So any polygon that has sort of an indentation. If it doesn't have an indentation, then it's called a convex polygon, like that, convex. And the way that you can tell, because sometimes it's like, does that have an indentation? Does that little piece count or not? I don't know. If you can take a line segment like, like this is a line segment. If you can put it inside a polygon and it crosses through the outside, then that means that it's concave. Like if I can put it anywhere and it's still going outside at some point, then that's concave. But if I can put it inside the polygon and it's never going to cross to the outside as long as both endpoints are inside the polygon, then it's a convex polygon. Does that make sense? So if this line segment has both of the endpoints inside the polygon and I can't make it go outside of it, then it's convex. So what if it had just a small indentation? Even if it's small, it would still be concave. Okay, cool. I think you get that. So I'm going to move on. Now, the next thing we're going to talk about is regular polygons. And does it mean regular, like they eat a lot of fiber? No, this has a different meaning. Regular means that something about it has the same length. Some of the segments have the same length, meaning this segment is the same length as this segment, which is the same length as this segment. So if the lengths are the same, if all of them are the same, that is called an equilateral polygon. That's actually what this is supposed to be a picture of, but it was a little hard for me to draw on my own. So look on page 6, the top left sort of shape, that's an equilateral polygon. And it kind of looks something like this. And it basically means all the sides are the same length. Okay, now this one is interesting because all of the angles are the same angle. So if I put a little hash mark there, that means this is the same as that, it's the same as that, same. That means they're all the same. This is an equiangular polygon. That's kind of fun to say. You should try it. Equiangular polygon. Okay, and the last one is a regular polygon. A regular polygon means that not only are all the angles the same, but all the angles and all the sides are the same. So that side is the same as that side. This is a regular polygon. Here are some other examples of regular polygons. It doesn't have to look exactly like this, right? These are actually all regular polygons. So this triangle has had a lot of fiber. It is regular, meaning that the angles are the same, the sides are the same. Okay, let's look at this regular quadrilateral. Remember, a quadrilateral has 4 sides or 4 angles. A regular quadrilateral has a special name called a square. So if someone asked you to define a square, I know it seems silly. You're like in 8th grade and saying, I know what a square is. But it means that it's a quadrilateral that's regular, meaning all the angles are the same, all the sides are the same length. Boom. If someone asks you to define what a square is, you just knocked that out of the park, baby. What about a regular pentagon? Remember, the pentagon is the one that looks like a tent. I'd stay in this tent. It's so cute. It's a regular pentagon that all the lengths are the same. A regular hexagon, so this is cool. I think this is a stop sign. I think it is, but sometimes I mess that up and it could be an octagon. I'm not sure. What do you think? What shape is a stop sign? Is it a hexagon or an octagon? I don't notice them very often. I just kind of slightly slow down when I see them. But anyway, that's a story for another day. Alrighty, pop quiz. Let's see if we can apply some of this knowledge so far. What's the polygon with the fewest number of sides? Pop quiz. What's the polygon with the fewest number of sides? Did you get it right? It's a triangle. Okay, so triangles have 3 sides, 3 angles, and you can't have a polygon with only 2 sides and 2 angles, right? So triangle has the fewest number of sides and can still be a polygon. Now, triangles are super cool, and we are going to study so much about triangles because you can get so much information. This is why they're super cool. The first thing to know about them is the sum of all the angles. Because if you add this angle plus this angle plus this angle, guess what? Always they add up to 180 degrees. This is just some cool magical fact about nature. They always add up to 180 degrees. How does that happen? That's just awesome. Let's just take it for what it is right now. So here are some examples of triangles. This one is a right triangle, meaning it contains one right angle. Just one. All you have to have is one right angle, and it's a right triangle. Cool. Okay. This one is called an acute triangle. Do you think you can guess why? All the angles are so cute. All the angles are less than 90 degrees, and that makes them so cute and little. So it's an acute triangle. If there's only one, even if there's only one fat angle, and a fat angle means greater than 90 degrees, then it's no longer cute. That is called an obtuse triangle, kind of like that word obese that I was equating it to before. So as long as it has one fat angle, it's an obtuse triangle. Now, if they all have the same angles, then it's an equiangular triangle. And if all of the angles are equal and all of the angles also have to add up to 180 degrees, can you guess what all the angles have to be? Of course you can. It's 60 degrees because 60 times 3, or 60 plus 60 plus 60, is going to equal 180 degrees. Okay, fun fact, huh? All right, so you can classify a triangle based on its angles. So that's how you classify a triangle if you're basing it on angles. Now, if you want to classify a triangle based on sides or relative lengths of their sides, then there's another way to sort of classify triangles. And another fun little fact here is the Greek prefix iso means equal. Okay. And the prefix, the root word of scales, it comes from scalos right there, and that means leg. Okay, to me this is really creepy because when I see this word, scalos, I think of skeleton. Does that make you think of skeleton when you see that? And of course, because a skeleton might have those bony legs, but they're equal. One leg is equal to the other leg in terms of length. And so this literally means equal legs or equal leg length. And so now that we know that, we're going to classify some of these triangles. I know it's really creepy, but I kind of like it because it helps me to remember that. So equal creepy legs. So here's an equal creepy legs triangle, or isosceles. That means iso, the same, scales, which is legs. That means two of the segments are the same. The third one, it doesn't matter. But think of this as like pants. Here's the feet. Okay. And those are the legs, and they're equal to each other. Okay, isosceles triangle. Okay, the next one is an equilateral triangle. That means all three sides, not just two legs, but all three sides are the same. That means the same equilateral. Equilateral means all the segments are the same. Okay, now the other thing you can have is all of them are different. So this is different than this is different than this. And you'll notice they all have different number of tick marks. That's indicating that all the lengths are different. And it also indicates that this is a scalene triangle. So if it's scalene, let's pretend that you have totally unequal legs and maybe your body is just like weirdly proportioned. You might have to have all your clothes made to scale. To scale. See the scale in that word? If you have to have it all made to scale, that means they're all different from each other. Okay? All right. Sorry that you have to deal with my crazy mnemonics here, but it helps me remember and hopefully it helps you remember. Oh, another fun fact about triangles, because triangles are full of little fun little miracles, I think. The angles opposite sides of equal lengths have equal measures. Now, I had to read this sentence in the book 5 times before it made sense to me. But basically what it means is this. If this length is equal to this length, then whatever angle is opposite of it is the same as the other opposite angle. So for example, here is the line segment. What angle is opposite to it or not touching it at all? It's this one. I kind of think of it as this angle is pointing to that side. So that's what's opposite that segment. Okay, so keep that angle in mind. In fact, I'm going to use this segment, okay, and this angle. Now, if we look at this other angle, let me do it in blue, this other segment, that is opposite this angle. And so what's really cool is that if the blue is equal to the pink, and which it is in an isosceles triangle, then that means that this angle, whatever it is, x, is equal to this angle, x. They're going to be the same angle. Are you kidding me? That's crazy. Okay, so let's do the equilateral triangle. The segment opposite the angle, okay, is going to be equal to an equal segment opposite that angle. So that means if this is equal to this, then this angle is equal to this angle. And it turns out in an equilateral triangle, since they're all equal, then all the angles are also equal. Okay? And this is cool too in a scalene triangle, because if none of the segments are equal, then none of these angles are going to be the same. They just won't be the same. All right, let's do some examples, because with math, it's hard to explain these things. You have to do an example to be like, oh, I get it now. Okay. This basically, example 2.1 says find x. So you've got a triangle here. It tells you 2 out of 3 of the angles. And so if we remember our fun fact about triangles, it's that all of the angles add up to 180 degrees. So I can say x degrees plus 130 plus 30 is equal to 180. And then 130 plus 130 is 160. So x plus 160 is 180. I'm going to subtract 160 from both sides so that that cancels out, and x is equal to 180 minus 160, which is 20 degrees. Now, I'm going to always check my answer. I'm going to put this back in here and see if that makes sense. And I think it does, because if we have 130 plus 30 plus 20, that makes 180. All right. Oh, we solved a mystery there. Oh my gosh, we are so smart. Let's do another example just to prove how smart we are. Okay, now, you knew it was going to get trickier, right? Now they want to know what is x and what is y, and they only give you one angle. So at first it seems like, I don't know if I can solve this problem, but they do give you another piece of information that is super helpful. These little tick marks, or those hash marks. That means that this segment is the same length as this segment. And what did we just learn? The opposite angles. So this is opposite this. and that segment is the same as this segment. So that means this angle must be the same as this angle. So that's so easy to figure out because now we know that if this angle is 50 degrees, then this must also be 50 degrees. It doesn't matter where I put that line, it turns out. It's always going to be 50 degrees. Did you know that? That's so cool. All right, but we still have to figure out why. And I don't mean why in a philosophical sense. I mean literally the letter Y. Okay, so we can use the other fun little fact about triangles, which is that all the angles have to add up to 180 degrees. So we have 50 plus Y equals 180. Let's combine that. 100 plus Y equals 180. If we subtract 100 from both sides, then Y is equal to 180 minus 100, which is 80 degrees. Now I'm going to put that in, make sure it makes sense. 80 plus 50, does that add up to 180? Sure it does. Yeah, we got that right. That's so easy. So easy, in fact, that I feel confident going into this third example. This third example is saying, what is X and what is Y? And this is very similar to the other one because look, they only give us one angle, which seems like, I don't know if that's enough information, but they also give us this length, and this length is the same as that length. So what does that mean? That means the angle opposite that, this one, is the same as the angle opposite this, which is this one. So, you don't have to call those two different letters, X and Y, anymore. You can just call it X and X because they're the same. They're absolutely the same. So now, if we say X plus 110 equals 180, now I can combine this and say 2X plus 110 equals 180. Let's subtract 110 from each side. That way I'm starting to isolate the variable, and I have 2x is equal to 180 minus 110, so that's 70. Now let's divide both sides by 2, so that cancels out. X equals 70 divided by 2, which is going to be what? 35 degrees. Now, of course, we have to check and plug that back in, see if it kind of makes sense with our picture. So if this is 35, this is 35, and I add those up, does that equal 180? Oh yeah, it does. So that's awesome. Now, because we got it all right, we're so smart, we get to move on to quadrilaterals. And I surrounded that word with a quadrilateral. Isn't that cute? Okay. Now, remember, a polygon with 4 sides is called a quadrilateral. And there are different types of quadrilaterals, just like there are different types of triangles. And here are a few of the different types. So first of all, we have a parallelogram. What's special about a parallelogram? Oh, they're so special because this side is parallel to its opposite, which is there. And similarly, this is parallel to this. So parallel has 2 pairs of parallel sides, and it has to have 2 pairs. That means these are parallel, and that's not enough. You also have to have these that are parallel, and then you have a parallelogram. So what if you have 2 parallel lines, but the other ones are not parallel? So this is not parallel to this, obviously, because they're going to cross at some point, right? Then you have a trapezoid. And the way I remember this is if you have an ugly crab like this. Actually, this is a cute crab. But if I wouldn't want it walking around the house though, right? So if I had a crab, what kind of quadrilateral would I put it in? I would put it at, whoops, my goodness, where's that crab going? He wants to escape. Oh my goodness, what just happened? Oh, no, what the? I don't even know how I did that, but it's like midnight, and I think I think my iPad is tired or something. Anyway, what I was saying is if you have a crab that you don't want walking around the house, what type of quadrilateral would you choose to put it in it? Put it in? I would put it in a trapezoid because look, it can't get out. It cannot climb these walls the way that they are, right? So it can't get out. So this is a good trap. It's a trapezoid. Now this one, but you know, the sides actually don't have to look like that. They could just be not parallel in a different way. Like this one could be slanted that way, but this one could be, I don't know, more slanted that way. And that could also be a trapezoid. Alrighty. Let's look at a rectangle. A rectangle is a super special parallelogram because it has 4 right angles. 1, 2, 3, 4. It's a stretched out square. It's 4 right angles, but the problem is it's not a square because all the sides are not the same. So if it has the 4 angles, but its sides are not the same, it doesn't quite qualify as a square. I'm sorry, rectangle, you're a little bit not as good as a square because a square is a little bit more perfect. A square has the angles the same and the sides the same. And rectangle, I'm sorry, you're just going to have to get second place because you only have the angles the same, not the sides. Whoopsie. Okay, let's move on to rhombus. Rhombus, you do not get the square award either, even though all your sides are the same, because you're kind of slanted, you know? The way I remember this is picture like a bus, like a school bus. What if you had a school bus that looked like this, but it was slanted like that because maybe it was going super fast, right? If you had a rhombus, like a school bus that was going super fast, it might look like a rhombus. It's like a square but slanted. Okay, this is the perfect square. And a square is just a rhombus, but it also has the 4 right angles. So maybe the rhombus came to a stop at a stop sign and turned into a square. I don't know, but it's a really perfect shape because all the angles and the sides are the same. So now you get to go do your homework and figure out more of these little mysteries, and it's going to be so fun. So lucky you. All right, have a great time doing your homework. Bye.